Here this center to this center is half pixel size from this center to the edge, and from there to here half pixel size. So if it is from here to here 15 meters and again here half of this, then what will be the value? So then you can combine together. So here in this case it is 30. Whatever the value we given a 30, suppose I wanted to move from to here, so it is 30 means we are moving half cell from this, so that means half the middle of the distance of the cell to the right. So then from there to the again center of this. So in this case it is, and then here 2000 means half cell of 2000 is 1000. So moving from here center of this to second cell, so it will cost you 1000. Here half you have to take 1000 in this case. In this case half of 30 is 15. So like that you convert whole map into a cast surface. Once the cast surface is there, so then you can see, visualize this. Suppose I go from like this, its value is increasing very high. Suppose I go like this, I go from here to here and this, so this cast is coming down. So that means you can use this cast surface to generate an optimum path. Once cast surface is generated, you can also ask the computer to calculate the optimum path. So this is optimum path analysis. What is told is this. So then so the same thing is produced here, and then whatever is the least cost, so then you put the values into one. Other values you are not concerned now, so then you put void. So like that if you see this, the optimum path is following like this. So but you can also generate using different other method, but this is the method what we use for raster type of analysis. Another is proximity distance. So proximity is a measure of distance between the features, that means distance in units of length, travel time, etc. So I go from one place to another, what is the distance between those things? So that way you calculate the distance, and then you can also use this for the buffer type of analysis, and then you can also use it for a T-sin polygons, and then the determination of accessibility drinking water. So all these things you can use if you use proximity analysis. So then another thing is I wanted to generate a buffer. So there is a rain gauge. This is rainfall stations. So like these are different rainfalls. These dots are rainfall, and then you can also calculate a distance from that place, rainfall, and then you are basically generating a distance from that. Once you generate a distance, for a decision maker, if you wanted to know that within each buffer how much area he has to consider for the development, so then you say that this yellow color it is showing that up to 250 meters center of that cell to that yellow color boundary, then you have 250 meters. So then he has made then blue color 500, and then again pink it is 750. So like that your distances are calculated. So it is required when you comes to some different applications, you will know more in the why buffers are required. So another is T-sin polygons. Particularly it is used when somebody is a water resources civil engineer, then they have a rain gauge stations. So then wanted to find out spatial distribution of the rainfall. So this T-sin polygon can be used effectively. So suppose I wanted to see that for A station of the rainfall, so there is some area of influence on for this. So what is that influence? So according to T-sin polygon, whatever is area covered under this, so it is considered that uniform rainfall all over this place. So in theoretically it is okay, but practically may not be exactly same. But if you say that point, from there you calculate a T-sin polygon. So similarly for other places, basically what you do is you join these rain gauge stations like this, and then you bisect these things with a line. So similarly for all these values you bisect those things, but basically you join these things and bisect those things, and then your area is formed. Okay, so then you can also do for B, C, D, E, F, etc. So this is method of T-sin polygon. Now here also then proximity sets. Suppose this is not true in case of India, it is done example of US. So suppose anybody who is investing something like our big businessman like Ambani, etc. or methyl for that matter, steel, who is doing steel business and then one of the richest in UK. So they, once they do such type of using a land, in case of US and all, if you are using a land, you should have also a fire station near to you. So if it is not, if it is far away, so then you have to construct a fire station. Government is not going to construct. So that for the safety measures. So here also the investor wanted to utilize existing one, so that if you go beyond some 1.5 miles etc., so then he has to invest for fire station. So that's why he has used only the places, fire hydrant places, the 10 value, and then he has taken only 1.5 miles. So that means only 1 pixel, 1.5 pixel he can move. So that means he has taken that, and then these areas, this is 5 is a clear land, so then he utilized only that areas. Otherwise, if you go beyond that, probably you can do that, but again it is additional expenditure, because you have to also establish or meet the requirement of fire stations. When you talk about a wildlife, this contiguity function and contiguity analysis are important. So then you have this is a forest land and then settlement. So then if it is connected, so then it is, if there is a land is there, like a forest is there, and then there is a patch is there, if it is connected, then movement for wildlife will become easier. Otherwise you go on breaking it, so then it will be difficult for the wildlife. Important thing is here is, you can also make map 1 to 1, you can make many to 1, and then 1 to many. So 1 to 1 is something like, if you have a land use map is there, and then that land use you convert into a cost, each land use type, so then that becomes, you are converting 1 to 1 there. Suppose I have many things, I have a village data, and then I wanted to convert them into district level information. So then village level data, block level data, all these is grouped together, and then make only one map for whole districts. Suppose there may be thousands of villages combined together, and then it is added for the whole district. So that type of analysis, only generalization, can be used for planning purposes. So if the reverse way you do that, so that becomes 1 to many. So then from the district to, if you wanted to distribute at each village level, so then district, you are having some data information, so then district you generate into different villages. So that means one is district converting into a many polygons, so then you are distributing it to all the villages. So these type of operations